Hello, we are Math VIP 이상진 and Cheonu of 포항제철고 High School. From now on, we will explain the Voronoi diagram lightbox, a mathematical parish.
What is a Voronoi diagram? Use a Voronoi diagram and create a Voronoi diagram lightbox.
The Voronoi diagram is a plot of a plane divided by a set of points closest to a certain point, which can be found in natural hexagonal columnar joints, dragonfly wings, turtle shells, and patterns on a giraffe's body.
To draw a Voronoi diagram, first, connect the two closest points on the plane. Then you draw a vertical bisector of the lines.
The following illustration is also a Voronoi diagram where the most important condition is that 2 points as close as possible must be split into planes to include 1 point at a time using a vertical bisector. That is, in the figure above, the plane is divided using a line that vertically bisects the imaginary line connecting the 2 points AB, a vertical bisector connecting the line BC, and a vertical bisector connecting the line AC.
The following example illustrates the use of Voronoi diagram. First, it is used to find close contacts in disease epidemiological investigations. In following figure, if any of the points of creation are referred to as COVID-19 patients and the rest of the points are not infected, the people closest to the infected are classified as close contacts. So it propagates from one point to the nearest point, and then it becomes the second propagation from that point. As mentioned earlier, the Voronoi diagram said that there is always one point in an area, which is the infected person. In case of an infected person, all other people in the area are classified as close contacts, so everyone in the restaurant where the infected person went is contacted to get tested.
If you look at the case of cholera, the dots here are drinking water pumps. For people in the area, the well is closest to access than other wells, so everyone who lives in that area will use the well. If a well is contaminated, it is highly likely that everyone living in the area would have consumed the contaminated water. These principles can be used to track the cause of cholera infection.
The following real-life examples illustrate the calculation and implementation of protein and molecular structures. If you draw a Voronoi diagram by dotting the center of the atom that makes up the molecule, you can calculate the structure of the molecule based on it. In the past, we used two-dimensional Voronoi diagrams, which are flat, making it difficult to consider the size of the different atoms that make up the molecules. However, we have now solved this problem using a three-dimensional Voronoi diagram.
Finally, let's talk about implementing 3D modeling with Delaunay triangulation. Delaunay triangular segmentation is a method of segmenting faces into triangles by connecting the generation points of the Voronoi diagram. It is using 3D modeling implementation because it divides the plane so that it is close to the equilateral triangle, allowing it to divide the area by a certain size.